Welcome to Learning with Mag, and I'm currently a mechanical engineering student, so I'm here to help you guys out. I'm currently using the 15th edition of the Hibbler Engineering Statics textbook, and I'm just going to go through the first homework assignment I was given using Pearson Plus. So if you're using it and you're kind of struggling with these problems, I'm just going to help you through it. One of the first things we're going to go through is significant figures, which basically is, I'm just going to use this decimal to help you guys out, just identify this. You can skip this if you already understand what significant figures are, but I'm just going to kind of do a quick recap just so you can understand what it means. So basically, any zeros before the decimal point and leading this main digits here, that's going to be insignificant. That's not going to be important. It's actually when you hit these numbers right here, including the 0 here too. So any full-on digits or zeros in between that's going to be significant. And this 0 afterwards is also going to be insignificant. So this is kind of just the main framework when you're learning it. A lot of times this is going to be in Chem 101 or just chemistry, so just make sure to know this. I'm going to have a worksheet in the description for you guys if you want to just practice it beforehand, because when you're doing these problems, even beyond this assignment, they're going to have to round up to a certain number of significant figures, and you're going to keep on doing that within engineering homework. So just know that this is going to be a significant part of it. And without further ado, I'm just going to jump into it. So I'm going to go into the first problem, which is problem 1.1. My homework is put into different parts, so I'm just going to go into each part and work through it. So my part A was that we were given 3.55555. Pretty big number. Now, I want you to put this into 3 significant figures. So they just want 3. So you can already see we're just going to round to the hundreds place. So just go next door, round it up, and that is just going to equal 3.56 meters. That's going to be your answer for part A. Make sure when you're doing this on your own, if you're just doing this along with your own homework in Pearson Plus, that your numbers are either the same or different than mine, because I know that on Pearson Plus they do generate different numbers, so make sure that yours is the same or different and apply. The next part is that I was given 45.706 seconds. So again, we're going to go to 3 significant figures. I'm just going to let you guys know this is Pearson's favorite number of significant figures. You're going to be basically doing that the whole time. So just, again, you're going to go to the hundreds place, so you're going to go next door, and it's going to be 45.7. Pretty straightforward. Make sure you don't forget your units, because they're going to count points for it. Okay, part C, I got 5,405 newtons. And again, we're going to put to 3 significant figures. But in this case, it's going to be special because you can't put 3 significant figures unless you change the unit. Or in this case, they change it if you put it normal. So you guys are probably thinking, hey, okay, in that case, just put this, right? That's probably what you're thinking when you initially just want to solve it. You can't do that because since I just broke down the rules for you guys, this decimal point is right here. And that means that any numbers right there for the zeros are not going to be compliant with it, and that just means the 5-4 is going to be significant, which is not going to help us in this case. So don't go into that thinking. What we're actually going to have to do is we're going to have to convert. So we're going to go from newtons to kilonewtons. So we have 1,000 newtons, and that equals 1 kilonewton. If you want to write down these conversions while I'm solving them through the video, feel free, because this homework is just going to have a ton of conversions. And that's going to equal to 5.405 kilonewtons. But you can notice here it's not 3 significant figures, so you're going to have to round it out. And that equals to 5.41 kilonewtons. So that's going to be your final answer there. And for the last part, it's going to be okay. And for this last part, I got 4,685 kilograms. And this one you could just easily round out. And that's just going to be 4,690. Notice that what's different here is that we have 3 digits before that decimal point, which means it's going to count as 3 significant figures. That's what makes it different than the last problem. The last problem only had the 5 and 4, which only made it 2. That's why we had to convert. Okay, into problem 2, which is problem 1.4. So when we're getting into this problem, we're going to go into different conversions. So I start off with 7 kilograms. And what they basically want us to do is find the weight in newtons. So you're going to need to know the unit conversion between kilograms and newtons. So 1 kilogram equals 9.81 newtons, which is going to equal to 68.67 newtons. Notice again, you need to make sure that it's 3 significant figures, so you're going to need a round. So it's 68.7 newtons. And I'm going to tell you here, if it helps, cross out the units that cancel out. So in this case, the kilograms are just going to give us our newtons. If that helps you when you're writing your own work, do it. It definitely helps the progression of the problem solving, and that's going to prevent further mistakes. The next one, I have 0.07 milligrams. And they want that answer in newtons again. So what's going to be different is that you're going to have to know the unit conversion from milligrams to kilograms, and then the kilograms to newtons. So the new conversion here is that 1 million. So 1 million milligrams equals 1 kilogram. If it helps to just write 1 million in scientific notation, by all means do it. I just like writing out it so that way it's easier to type in the calculator. Then we're going to have 1 kilogram is going to equal to 9.81 newtons. So we're getting that from the last problem here, that unit conversion. Cross out all these other ones that are canceling. So that way you're just left with newtons. And that's going to give you 6.87 times 10 to the negative 7 newtons. So when you put this in a calculator, you're going to notice it's this really small decimal. Make sure to take that and put that into scientific notation, and then make sure to put your units when you're entering it into Pearson Plus. That's going to help make sure that your answer is counted as correct. Okay. For part C, I have 860 megagrams. Now, the difference between the megagram and the milligram is going to be this M is going to be capitalized. So make sure that you capitalize your megagrams so you don't confuse them in the unit conversion. Because here, I'm about to show you guys. So 1 megagram is equal to 1,000 kilograms. You could tell that there's a huge difference with the unit conversion between a kilogram and a megagram compared to a kilogram and a milligram. So make sure you write your units properly. And if you read chapter 1 of your textbook, it's going to explain that. So I'm just going to use the same unit conversion we used to 1 kilogram to 9.81 newtons. Cross out those units. And our answer is going to be 8.44 times 10 to the 6 newtons. And now I'm going to go into problem 1.12. Okay, so in problem 1.12, you're basically going to be going from slugs to metric units. So slugs, if you know, is basically just pounds times seconds squared over feet cubed. So it's a different unit. What these problems are basically going to challenge you to do is use those unit conversions. So that way we can get out of using those slugs and get into using, in this case, is going to be, the final answer is going to be in megagrams over meters cubed. So I was given this 1.94 slugs over feet cubed. The first thing that you're going to notice is that you can't cancel out both these units to get into metric units. So you're going to have to cancel parts of this first, and then that's going to get you to the final answer. So I already know that 1 slug is equal to 14.59 kilograms. Already there in that step, you're going to cancel all your slugs. And now you have kilograms over feet cubed. Your next conversion is going to be 1 foot cubed over 0.0283 meters cubed. And that's going to cancel out our feet cubed. So notice now that we just have kilograms over meters cubed. And now we just have one more conversion. And that's going to be 1 kilogram over 0.001 megagrams. And that is going to cancel out our kilograms. So that way, when we finish this problem, our answer is going to be megagrams over meters cubed, which is 1.00 megagrams per meters cubed. Now you're probably wondering, why did I do that last conversion? Like, we could have just finished with kilograms over meters cubed. That would have been metric. You're right. But our answer would have been 1,000. And when you're writing 1,000, that's not going to be 3 significant figures. 1 is going to be that 3 significant figures. So make sure that if you need to convert, it's completely fine. It's going to be a little bit more work, but that's going to make sure that you have enough significant figures. Okay, I'm going to jump into problem 1.13. And I only got one part for this problem as well, so it's going to be called part A, but it's just going to be like one problem in there. So I was given 5.26 slugs over feet cubed. So it's basically going to go through the exact same process we just went through for the last problem. So all the unit conversions, everything is going to be exactly the same, and the answer is even going to be in the same units. So if you want to look at the work, just look at the last problem. I'm just going to put the answer here. I would suggest taking this problem and just going through steps by yourself and see if you get the same answer as I did. So if you did it correctly, you should get 2.71 megagrams per meter cubed. If you got this wrong, just make sure to check your decimal points in your unit conversions and make sure that translates correctly to your answer. So now I'm going to problem 1.16. So for this part, is kind of going to go into doing unit conversions, but only in metric conversions. So I'm going to explain it as I go through. So I was given 160 kilonewtons squared. So make sure when you're doing this problem, do not make the same mistake I did. Make sure that you're squaring both the unit and the number, because that's going to change your answer significantly. It's not going to just be 160 kilonewtons squared. No, it's going to be a big number, kilonewtons squared. So in this case, it's 25,600 kilonewtons squared. And what we're going to have to do is take the standard kilonewtons to meganewton conversion and square it. So basically, I already know. So we're basically going to take the unit conversion and square it. So it's going to be 1 kilonewton equals 0.001 meganewtons, and we're going to square that whole unit conversion, which is going to give us an answer of 0.0256 and squared. Make sure that you're going to have this in 3 significant figures though, so it's going to actually be 2.56 times 10 to the negative 2 meganewtons squared. And for the next problem, it's gonna be millimeters instead. So start the problem with 0.007 millimeters squared. And again, it's squaring this whole statement, so make sure you're squaring both the number and the units. So that is going to be 0.000049 millimeters squared. And again, we're going to take a standard unit conversion and we're going to square it. So in this case, 1 millimeter is going to be equal to 1,000 micrometers. And we're going to square it. And when we get that, it's going to be 49. Micrometers squared. When you're writing it into Pearson Plus, just make sure it's going to be typed out as 49.0 micrometers squared. And that's just going to make sure, again, 3 significant figures. So for part C, it's going to be a special case because you're starting with a cubed expression instead. So instead of squaring everything, you're going to have to cube everything inside this expression. So in this case, 370 meters, which you're going to have to cube, which is going to equal a very big number. So it's going to be 653 000 meters cubed. And we're going to again take a standard conversion and we're going to cube it. So in this case, not square it, cube it. That's going to make sure that our units are correct and make sure our final answer is going to be accurate. So 1 kilometer is 1,000 meters. And we're going to cube it. And that's going to give us an answer. I'm going to write it in scientific notation. 5.06 times 10 to the negative 2 kilometers cubed. Okay, and the last part of this video is basically just going to be standard conversions. So I'm going to give you the unit conversions and I'm going to let you guys solve these on your own, but I'm just going to give you those conversions so that way you have somewhere to start. So for the first problem, oh, by the way, this is for problem 120. So the first unit conversion I'm going to give you is 1 pound equals 0.381. 0.81 slugs. For the second part, you're going to have to use this conversion, so 1 slug okay, and that's just going to equal 14.59 kilograms. And the last one is just going to be 1 pound. Equals 4.448 newtons. So basically use these unit conversions to solve parts A through C, and that's going to help you solve those problems. And that should cover, for me, it covered for my Pearson Plus questions 1 through 6. And then 7 and 8 are more logical questions. So that's going to ask you more about physics related questions. So what is, which force is acting upon what object, and where is that force coming from and what direction. So for those, I would advise just imagining that you're moving that object or you're kind of pushing that force on it. They're going to give you statements, and you're just going to solve those. And that should be it for homework number 1. I hope this helped. If you want more videos like this, subscribe, and I'm going to go through the different homeworks for statics with the Hibbler textbook if you need any help with it. If you guys want me to go over any other topics or any other homework help, then feel free to comment below. And I will be putting worksheets in the description so that way you guys can review these kind of problems. If you go into Pearson Plus, there actually should be a practice mode that you guys can do. If you don't have Pearson Plus, then I'm just going to have that worksheet for you guys. You can go through it. It's going to have an answer key as a separate page, so that way you guys can check your answers. And I hope that you have help with this video with your engineering journey. And thanks for watching Learning with Mag.